So I ended up making a liar out of myself last time and did not get through 2 examples. I do want to do one more because we haven't looked at a decay problem in this context. And then we'll be at the end of the chapter, and you can go ahead and do your MyMathLab stuff and be ready for the test. First, before we start, there are a couple problems in this section that deal with something called Newton's law of cooling. It's similar to exponential. Well, it's just sort of a special case of exponential growth or decay. It's kind of interesting, but it's not really necessary. So go ahead and skip those couple problems. I'm not sure which ones they are. There'll be probably about 3 or 4 problems from the end of the assignment. So let's look at one more. We did a depreciation problem. I don't even remember what it was. It was a couple days ago now. But we did do one where we had something that was decreasing. So let's look at that here. Let's say that in 2014, we bought a car for $25,000. And let's say that today, we still got that car and it's worth, let's say, $10,000. I would like to know if I keep that car another 5 years, so to 2025, I'd like to know how much that car is going to be worth. And suppose I was a business or whatever, had a plan that I would want to get rid of a car when it reached a certain value. I want to know when the value of that car is going to get down to $1,000. And so standard input-output form here. We've got our year and our money. And we know the form of the equation. We're going to start with a value of 25. So our value after t years is going to be 25 e to the rt. And we also know that after 6 years, the value of the car had dropped to 10. So if we put a 6 in for t, we have 25 e to the r times 6, and we put 10 in for the value, now we have an equation that we can solve like last time. We can solve for the value of r. And it's going to be the same as last time. We're going to divide both sides by 25. So we'll get 10 over 25 equals e to the r times 6, or 6 times r, doesn't matter. Then we're going to do the natural log of both sides. And then we're going to bring that r times 6 down in front, and the natural log of e is 1. So we're going to get that the natural log of 10 over 25 is equal to 6 times r. And then we're going to divide both sides by 6. And that's what we're after. Our rate is the natural log of 10 over 25 divided by 6. Now remember, there's a shortcut for that. It's just going to be the natural log of new value over original value divided by the time period, so the 6 years that have passed. And we can pop that in the calculator real quick. Natural log of 10 divided by 25. Don't forget to close the parentheses, and then divide that by 6. And we get negative 0.153. Right? That's consistent with what we looked at before. If we get a negative rate, that means it's a decrease, and that's what happened here. So now to answer our questions, we've got our equation, v of t equals 25 e to the negative 0.153 t. And we can do this by hand, or we can put it in the calculator. Right? We've been putting stuff like this in the calculator all semester, no challenge. 25 e to the negative 0.153 t. And we got to set up our window. Well, we're going at least to 25, maybe a little bit further, or 2025. So let's go to 2030, which would be 16 years after 2014. I'm just going to round that up to 20. And our value is starting at 25 and dropping. So if we set the top of the window at 30, we'll catch the graph. So we can see the value of the car decreasing more rapidly at first and then leveling off. Remember the questions we wanted to answer. What would it be worth in 2025? Well, that's going to be trace. Will tell us the value in any year. And 2025 is 11 years after the car was purchased. So we just put in 11. You'll see that it'll be worth $4,000, right? Because the numbers that we put in, our Y values are in thousands. So we get 4.6. So it's going to be worth $4,600. And when will it drop to 1,000? That's another one of those. Go to Y equals, put in the number for Y2. We want to know when it hits 1,000. And then we just look for where those graphs intersect. And it looks like I set the window just about right. Looks like we hit those graphs hit each other right by the edge of the window. Second trace 5, enter, enter, enter. Nope. We can tell those graphs are going to intersect, but we do have to go out a little bit further. So I'm going to extend that to 30. See if we can find that intersection point. Second trace 5, enter, enter, enter. And we see that after 21 years, so 21 years after 2014. Oh, you're going to make me think. 2014 plus 21. In 2035, our car will be worth $1,000. All right, that's the end of the chapter, end of the section, end of the chapter. So get going on the homework and get ready for that test. I'll talk to you again soon.